All right, welcome everybody. In this video, I want to talk about how we can import external data. In this case, that external data is going to be data stored in a CSV file online into R and stored as a data frame. And there are all sorts of different ways that you might be able to do this. So I'm just going to describe one or two possible ways that we could do this. And then we'll continue our exploration of how we can slice and subset data frames in R working with that data frame. Okay, so one really kind of general function for importing data frames is what's called the read table function. And the data that we're going to import, let me just show you what it looks like in its raw form. It sits online and here's the address that you can see where it is. It's in GitHub. And it looks like this. So it is a comma separated file. So it's all mushed up over here. It's got a bunch of headers over here that are kind of like the variable names. And then it's got all this data over here. And each entry is separated from the next by a comma. That's what makes it comma separated. And I would like to take this data, which is not living in R at all, import it into R, and store it in R with this structure of a data frame. And it's surprisingly easy to do so. So this is not living in any sort of package in R right now. This is my own data that I stored in GitHub. So we can use the read table file to do this. The read table file is the read table function, excuse me, is nice because it works with comma separated files and it works with like tab delimited files and more general types of files. And so in this case, let me just show you how it would work. I would need to know the HTML, the link for where my data is, which is over here. This link can also be like a link to a file location on your computer, I should say as well. So this doesn't need to be a web address. This could be a file location on your computer. So you've got this data stored in a file someplace that can be in a cloud online, that can be on your computer. So first you need to enter a file. Where is the file? Could be online, could be on your computer. That might be all you need to do. So you could just do like read table file, bam. Okay, that might be enough. You might want to indicate whether or not the first row of your file has headers or not. Sometimes the first row of your file just doesn't have any headers at all, and you might need to enter those yourself in R. Sometimes that first row already has the headers. And in my case, my first row are the variable names. So that's why I have header equals true in this case. And then I can indicate what is separating the columns from each other. And in that case, this is the commas over here. And what's nice about the read table function is that you can customize this to other sorts of characters, other sorts of ways of separating columns. So for those that might be like used to using Excel, this is sort of like your text to columns sort of operation in Excel. This is how you're chopping up and defining different variables, how it's going to create the different columns in your data frame. So let me run this code cell here. Nothing got printed to the screen because all we did was create a data frame called bike store. If we want to see kind of what the data frame looks like, I can take a look at the structure of bike store using the structure command. And I can see here there are 13 variables in this data frame and 20,000 observations. So this is a really large data frame, 20,000 observations, 13 variables. There's no help documentation for this. because this is not from any sort of package. So I can try very hard to say like, hey, tell me something about bike store. It's going to say there is no bike store documentation. Try double question mark. This is like, hey, do you really have a question mark? It's going to say no. You can keep adding question marks here. There's no such thing as a triple question mark. I just made that up. But there's no help documentation since this is not coming from a package. This is like um, my own file here. So this is all we can see about this data frame. It's got 20,000 observations and 13 variables. And I can see some of them are being stored as integers, some of them as characters, some of them as logicals. And I get some sense of like what the values look like in here with this structure command. Another way to load, in particular, CSV files is to use a read CSV command. So that's basically just doing the read table command with this default separator being a comma. And it's also going to assume that I have headers here as well. So I don't need to include any options here. So all I did was say read CSV and enter the file name. And again, this file doesn't need to be stored online at a web address. This could be a local file. Instead of a link to a web page, this could be like a link to a file path on your computer. So I'm just going to load this again. I'm still calling this the same data frame bike store. And here I'm going to run a summary command. This will give us like a little bit more detail about the data. But here I can see all 13 variables in this data frame and get a summary of them. The variables that are being stored as characters, the summaries are not very useful for me. These I probably want to store as factors, like the brand names I can see over here, probably make more sense to store these as factors. The order status, I probably want to store these as factors. All the product line, I probably want to store these as factors because I want to group my observations into Solex versus Trek bicycles and so on. So that's one issue that I see in the data. A lot of my variables that are being stored as characters, I probably want to store them as factors. Another problem is that there are NAs. The standard cost has some NAs. The first product sold date has some NAs. Online order has some NAs. So there are some missing data in this. What else? Yeah, so those are a couple of issues. So maybe before we start to go in and play around with this data set, let's do some cleaning up of this data. And so here's a really nice function for cleaning missing data. There's a function called na.omit. So this is going to remove every row in the data frame that has an NA value at least for somewhere, right? For one of the variables. So if I do bike store, so if I do NA omit bike store, that removes all of the observations that have an NA somewhere. And now I want to store that result someplace. So I'm going to store it back on top of the original bike store data frame. So that will scrub all of the missing data observations out of the bike store data frame. All of these commands over here, right, are going to convert all of these various character variables from characters to factors so that they're going to be treated as categorical variables. That's what each of these commands are doing here. And then lastly, I'm not going to worry about all 13 variables in this data frame. I am going to just slice out a subset of the data frame from columns 6 through 12. So column 6, let's see, this is 1, 2, 3, 4, 5, 6. So sorry, 1, 2, 3, 4, 5, 6. We're going to start with like order status and go up to standard cost. I think that this would be column 6, 7, 8, 9, 10, 11, and 12. So we're going to keep columns order status, starting at order status and up to standard cost, and exclude the rest. And we're going to now store this new data into a data frame that I call bike clean. Okay, so now we're going to have a new data frame that we're going to work with, which is like cleaned up bike store data. So this is called bike clean, and we'll print out a summary of that new data, which is called bike clean. So again, we're not looking at all 13 of the original variables in the data frame, but just some subset of them. We no longer have any NAs in the data frame. All of the variables that are categorical variables are now being stored correctly as factors. So the summary of brand is now correctly counting how many observations, how many sales did we have for each of these brands, right? How many sales were approved versus canceled, and so on. Okay, so now we've got our data loaded, cleaned, and ready to go for the rest of the analysis that we're going to do in this module. So I will stop at this point in this video. You definitely want to make sure you've loaded up the bike store data and cleaned up the bike store data in order for the rest of the code cells for the rest of the videos to work smoothly in this notebook. Thanks, everyone.